Hello everyone, welcome to Top Scholars, the smart learning app. Today in this lecture, we are going to look at something really important. So if you are in class 10th in the CBSE board, then you must have seen this name, that is light, reflection and refraction. This is one of the chapters from your syllabus in science book, isn't it? So this is one of the very important chapter from your syllabus. And as you know, some questions, or you can say sometimes many questions are asked from this chapter. So what we are going to do here is, in this lecture, we are going to look at some of the previously asked questions that were asked in the last 5 years in the board examinations of CBSE, okay, for this particular chapter. Okay, so what exactly was asked and how many questions and for what marks they were asked, everything we are going to discuss here. And what we are going to do is, we will not be able to solve all the questions, but we will definitely solve some of the important questions, and definitely we are going to discuss the answers to all the questions, okay, or you can say the probable answers to all the questions, isn't it? So now let's get into this and let's see how many questions and which question exactly was asked in the last 5 years. What exactly was the trend that was followed since these last 5 years for this particular chapter. Okay, so here it is. Let's first of all have a look at this simple table which actually indicates us how many questions were asked in each year for 1 mark, 2 mark, 3 mark, 4 mark and 5 marks, isn't it? So first of all, starting with the year 2019, as you can see here, there was one question for 1 mark, then we have got one question for 2 mark, and we have got one question for 5 mark. Which question exactly it was, we are going to have a look at that also, okay, as we move on into this lecture. Then secondly, if you look at this, in the year 2020, we have got one question for 1 mark, one question for 3 mark, and we have got one question for 5 mark, isn't it? So here in this third year, that is 2021, we have got one question for 1 mark and we have got one question for 5 mark. So if you look at this carefully, 5 marks questions are asked consecutively for 3 years, isn't it? So there are 3 questions for 5 marks in 3 consecutive years. So we can see here that this chapter will give you good marks if you prepare for this chapter, isn't it? Then later on in the year 2022, we have got 17 questions for 1 mark, isn't it? So many questions are there, okay, for the year 2022. Then here in the year 2023, we have got one question for 3 marks and then we have got one more question for 4 marks, isn't it? In this way, if you look at this total number of questions, so there are 21 mark questions, then one question for 2 marks, 2 questions for 3 marks, we have got one question for 4 mark, and we have got 3 questions for 5 marks in the last 5 years of the board examinations, isn't it? So you can see here that 3 questions have been asked and they are for total 15 marks. So that's why this chapter is quite important to us, because this might provide you good number of marks, isn't it? So this is the trend, okay, and these are the number of questions that have been asked. Now this simple chart, okay, is represented in a graphical form here. As you can see, in the year 2022 we had 17 questions. That's why you can see a very large building over here, isn't it? And in these years, you can see small bumps are there, isn't it? Each of these different colors are indicating different types of questions, isn't it? So this is the same statistics that is being represented by a graph. Now let's move into the actual questions that were asked. Okay, first of all, we are going to start with the year 2019. Remember, we are not going to look at the solutions for all the questions, but we are just gonna have a look at these and just discuss the probable solution for these questions. And at the end of the lecture, we are going to actually solve some of the questions, okay, that are present over here. Now, the first question from the year 2019, and as you can see, it is for 5 marks. That means it's a large question. So here, the question is very simple. An object is placed at a distance of 30 centimeter from a concave lens of focal length 30 centimeter. And the question is very simple. Use lens formula to find distance of the image from the lens. Secondly, we have got very simple question, list 4 characteristics like nature, position, okay, etc. of the image formed by the lens. And lastly, we have got the third question, draw ray diagram to justify your answer for the part 2. Okay, so it is very simple question. We are going to have a look at this question later on at the back of this lecture. Okay, second question over here is for 2 marks, as you can see here. Okay, so it's a short answer question over here. List 4 precautions which a student should observe while determining the focal length of a given convex lens by obtaining the image of the distance object on the screen. Okay, so here we have to just list out some precautions that we have to take. Like for example, if you are finding out the focal length of a lens, the first thing that you have to take care of is that you must have a lens and the screen. Both of these must be on the same level, isn't it? If they are not on the same level, then definitely you are not going to get a proper image of that distant object on the screen, isn't it? So this level of this lens and the screen must be same. Then secondly, as we know, there has to be proper illumination. That means proper intensity of light should be there so that we will be able to see the object very clearly, isn't it? And in this way, there are many such precautions that we have to take, okay, and we have to list those precautions over here. Okay, so this is the second question. Now moving on to the next, that is year 2020. So here we have got a MCQ question, as you can see, and it's an optional question. That means we have got 2 questions out of which you have to just solve one, but we are going to discuss both. So over here, the law of reflection holds true for what? So we have got 4 options here. First option is plane mirror only, concave mirrors only, convex mirror only, and then last is all reflecting surfaces. So this is a quite easy question, isn't it? Law of reflection, as we know, it holds for all kinds of surfaces, isn't it? That's why the option D is the correct option for this question. Next question here is, when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. This image is what? So we have got 4 options: real, inverted, virtual and inverted, then virtual and erect. So over here we have got a concave mirror, isn't it? So in case of a concave mirror, when the object is kept within the focus, then we know what happens, isn't it? In this case, we get a virtual image, isn't it? We get a virtual image which is erect, isn't it? So the correct option in this case is virtual and erect, isn't it? So this is our correct answer. This is just for 1 mark. It's an MCQ. Now moving on to the next question from the year, again from 2020. So the question is, why is Tyndall effect shown by colloidal particles? State 4 instances of observing the Tyndall effect. Okay, so over here we have to talk about the Tyndall effect, okay, and why it happens by, or we can say why it is shown by the colloidal particles, and we have to talk about 4 instances of observing the Tyndall effect. Now we know what happens in case of a Tyndall effect. So whenever we have got microscopic But some colloidal particles, like for example, you can take a clean water, and in that clean water you can dissolve some Dettol, and if you shine a laser through the glass, then you will be able to see the path of that laser light. Okay, this happens because those colloidal particles are able to scatter the light, okay, in all directions, and that's why the viewer or the observer will be able to see the path of the laser light that has been shined onto that particular glass. So that is one of the instances where we can see the Tyndall effect. Secondly, we can see the Tyndall effect in case of a room, or we can say a hall, in which there is a small hole in a window or somewhere else, through that hole, if the sunlight is coming, and sometimes while cleaning the house there is some dust in the air, and we are able to see the path of that incoming light through that hole, okay, just because of this Tyndall effect, isn't it? So what happens over there is those dust particles are scattering the light in all directions, and due to this scattering of light, we are able to see the path of the sun rays that are passing through that small hole into the window or something else, or maybe the walls. Okay, so these are some instances where we get to see the Tyndall effect. In this way, you have to also list 2 more instances. Okay, so this is Tyndall effect. Now moving on to the next question, differentiate between a glass slab and a glass prism. What happens when a narrow beam of monochromatic light and secondly white light passes through glass slab and a glass prism? So we can simply differentiate between these glass slab. Okay, first of all, the glass slab is somewhat like this. It has got its both surfaces parallel to each other, isn't it? So over here you can see that both surfaces are parallel to each other. And if you talk about a prism, in this case we have got 2 plane surfaces. We have got one rough surface here, and we can see there is a particular angle between these 2 refracting surfaces or the plane surfaces. Okay, so here we can see that the 2 surfaces are parallel. In fact, these 2 are also parallel, but here we can see that the 2 refracting surfaces are not parallel. So this is one of the major difference between the glass slab and the glass prism. Also, we have to talk about what happens when a monochromatic light passes through both of these. First of all, if a monochromatic light will pass through it, it will be refracted a little bit. That means it will change its path a little bit, and then here again when it comes out, okay, again it will become parallel to the incident ray. This is incident ray, this is refracted ray, and this is the emerging ray. So in case of a glass slab, the incident ray and this emergent ray or emerging ray, they are always parallel, okay, according to the Snell's law or according to the laws of refraction. But if you talk about this, the glass prism, if a monochromatic light enters here, again first of all it will be refracted. That means its path will change a little bit, and then here it will be again refracted, and again it will be deviated a little bit. Okay, so here we can see that the incident ray and the emergent ray are not parallel, whereas here they are parallel. So this is for monochromatic light, but in case of a white light, it is quite different. Here in this case, okay, when the white light will be passing through this glass slab, so here each color, okay, each color will be deviated by different angles. Okay, here also you can see first there will be a red color here, and at the last we will have this violet color. We are talking about a white light which contains, okay, or which consists of all the wavelengths of light, okay, starting from red to violet. Okay, so here red will be deviated by small angle and violet will be deviated by a large angle. Okay, and again when it comes out, all these rays will be parallel. Okay, but if you talk about this prism, in this case all these colors, okay, all these colors again will be spread out, okay, and when they come out, okay, they will be deviated by different angles, and here the angle of deviations for each color is going to be different, smallest for the red color and largest for the violet color. Okay, so this is what is going to happen in case of white light. Okay, so this is the answer that is expected. Okay, you can draw these diagrams and you can explain in words also. Moving on to the next question now from 2020. This is a large question for 5 marks. Okay, so the question is, draw a ray diagram in each of the following cases to show the formation of image when the object is placed. First case is between optical center and principal focus of the convex lens. So here we are going to talk about the convex lens. Then secondly, anywhere in front of the concave lens. Okay, so here it is concave, and then at 2f of the convex lens. Okay, here they have also asked one more thing, that is state the sign and values of magnification in above mentioned cases 1 and 2. So case 1 and case 2, we have to also talk about the values and sign of the magnification. So this is a quite easy question. So for example, let's talk about this first case. Okay, over here we are talking about a convex lens and we are talking about the object which is between optical center and principal focus. So let's try to draw this ray diagram. So let's consider that we have a convex lens somewhat like this, and let's say this is the principal axis, this is the optical center O, and let's say here is the principal focus F, and here is the principal focus F on the other side of the lens. Now let us say that the object is somewhere here, okay, and now what we are going to do is we are going to trace out some of the rays. Okay, so let's say this is the ray that is parallel to the principal axis, and we know, okay, that the ray which is parallel to the principal axis always emerges through the principal focus. So let's say this is that ray which is emerging out through the principal focus. Secondly, we have the ray which is passing through O. The ray which passes through O, okay, that ray always goes undeviated, is it? So over here, these two rays are not meeting anywhere, okay, they are neither parallel to each other. Okay, so if you can look at these two rays carefully, okay, they are diverging from each other. So for an observer over here, okay, this observer will not be able to find that point which is meeting somewhere, okay, or coinciding somewhere. So over here, what we are going to do is we are going to trace these rays backward, okay, and wherever these rays meet, okay, at that point the image will be formed virtually. Okay, so this will be the virtual image that will be formed for this particular case. Okay, and in this case, as we can see, a virtual, erect and magnified image of the object is formed, and this is the particular case that is used in magnifying lenses. Okay, so this is one of the diagram that we have drawn here. Okay, there are a few more cases that have been given that you have to also draw. Also in this case or in the two cases, we have to talk about the magnification, whether it is positive or whether it is negative. So we know magnification is nothing but image size h dash and divided by object size h. So here, since image is bigger than the object, definitely this magnification is greater than 1, and we can see here both image and object both are above the principal axis. So definitely both of these are positive. So therefore magnification is a positive number, isn't it? So this is going to be the value and sign of the magnification. So for this question, we have another option given over here. As we can see, there is another question. So out of these two questions, you can solve any one of these. So both of these questions are for 5 marks. So the question is, an object 4 centimeter in size. So the size of the object is given, is placed 25 centimeter in front of a concave mirror. So it's a concave mirror of focal length 15 centimeters. So that means focal length is given to us. Okay. The question is, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So we have to over here find out what is the image distance. Then second question here is, find the size of the image. So how big the image would appear or how small it would appear, that is what we have to find out. Then third question is, draw a ray diagram to show the formation of image in this case. Okay, so this is what we have to find out over here, and it's a very easy question. As we know, over here we have to use the simple mirror formula or mirror equation. Okay, so let's get into this and let's try to solve this question in short. So first of all, what is given here? So this size of the object is given, that is 4 centimeter. Then this is 25 centimeter is the object distance and 15 centimeter is the focal length. So let's use these numbers and try to find out what would be the answer. So let's write down what is given over here. So first of all, size of the object is given. Let's call this as h, and it is 4 centimeter. Then similarly, the object distance, that is u, is given and it is 25 centimeters. Similarly, the focal length is given and the focal length here is 15 centimeters. But it's a concave mirror, and for a concave mirror, if we apply the Cartesian sign convention, then this would become positive, then object distance would become negative and the focal length will also become negative. Now let's use the mirror formula, that is 1 upon f is equal to 1 upon v plus 1 upon u. And what we want here is the image distance, right? So 1 upon v, if we just rearrange this equation, 1 upon v would be equal to 1 upon f minus 1 upon u. So let's put all the numbers. 1 upon v would be equal to, what is f? F over here is minus 15 centimeter, then minus 1 upon u. So u over here is 25 centimeter, it's minus. So minus minus, it would be plus. So after rearranging, what we get is 1 upon v is equal to 1 upon 25 minus 1 upon 15. So what we can do is we can cross multiply these two, or we can also make the base same for these numbers. Okay, or we can cross multiply also. So this would become 15 minus 25 divided by 15 into 25, and after we solve this, what we get is 1 upon v is 15 minus 25 is minus 10, and over here this is 25 into 15. So 25 into 15 would be 375. So v would be equal to minus 375 divided by 10, and the final answer would be over here minus 37.5 centimeters, and that would be the image distance. That means that the screen must be placed at this distance from the mirror in order to get a sharp image of the object. Now one more thing that we have to find out over here is the size of the image. So for that we can use the formula of magnification, and the formula for magnification is size of the image, let's say it is h dash divided by size of the object, it is h, and it is also equal to minus v upon u, isn't it? So we can use this formula, this one, and using this formula we can find out the size of the image. So h dash would be equal to minus v upon u into h. So let's put the numbers. So over here, what is v? V is the image distance. So here it is minus, this is 37.5 divided by u. What is u? U over here is minus 25, and here also this is negative, into h. What is h? H is just 4. Okay. Now this h dash can be also written as this 37.5. Here you can see this minus sign and this minus sign would be cancelled, and what remains over here is this 37.5 is nothing but 375 divided by 10. So this is 10 into 25 into 4. So now this can be easily solved. So this, if you divide this, this would be 15, and h dash would be equal to 15 4 is 60, and 60 divided by 10 is 6 centimeters. So the correct answer over here would be 6 centimeters. So size of the image is going to be 6 centimeters. So this is the question. Now there is one more thing that we have to find out, and that is the ray diagram, or we have to draw this ray diagram over here. Okay, and let's draw the ray diagram. So for that, first of all, we have to draw the concave mirror. Let's say this is the concave mirror, and let's say this is the principal axis. This over here is the pole, let's say. Here is, let's say, the principal focus F, and as we know it is 15 centimeter as it is given. And the object is placed at 25 centimeters. So that means if C is over here, that is twice F is here, then the object must be placed somewhere down here. So let's say object is here. Now what we have to do is we have to trace the rays, okay, that are emanating from this object. So the first ray that we are going to consider is the ray which is parallel to the principal axis. So this is, let's say, the one of the rays, and the ray which is parallel to the principal axis always travels through F. And this ray, let's say it goes in this direction, and then the second ray that we are going to consider is the ray that is passing through F, isn't it? So the ray which travels through F is going to travel straight, somewhat like this, okay? And then the another ray that we are going to consider is the ray which is incident at pole. So this ray, after being incident at the pole, is going to follow the laws of reflection, and definitely the angle of incidence and the angle of reflection is going to be same. So after reflection, it would travel in this direction, and all of these rays, as we can see, they are meeting somewhere here, okay? So here the image would be formed. So if the object is denoted by A, B, then the image we are going to represent by A dash, B dash, okay? Here if the size of the object is H, size of the image would be represented by H dash. This is the image distance, that is V, and this is the object distance U, okay? So this is going to be the ray diagram for this particular case that we are studying, okay? So this was a pretty easy question. Now let's move on to the next question. Now we are going to move forward, okay, to the next question. there were some more questions in that previous question that we can also answer. Okay. So over here we have got another question, as you can see, from the year 2021. Okay, here this is a different kind of a question. It's an assertion and reason kind of a question. So here assertion is given, that means a statement is given, and the reason for that particular assertion or statement is given. So we have to identify whether that assertion and reason both are right or not. Okay, if the assertion is right, or if the reason is right, or whether the reason is the correct reason for that particular assertion or not, that we have to identify. So the question is somewhat like this. Assertion says a concave lens of very short focal length causes higher divergence than one with longer focal length. Okay, so here they are saying that a lens which is a concave lens, okay, of very short focal length, it causes higher divergence than with longer focal length. So definitely this is true, isn't it? As we know that the power of a lens is inversely proportional to the focal length, isn't it? So since it is inversely proportional to the focal length, definitely more divergence will be created if this focal length is small. If this is small, that means the power is large, and if the power is large, that means divergence will be large. Okay, so this statement is definitely true. Then the reason is the power of a lens is directly proportional to its focal length. That means here they are saying power is directly proportional to the focal length, but we know this is not true, isn't it? This is wrong. That means the reason that has been given here is not correct. So both assertion and reason are correct. So here the options are given. So we have to identify which option is correct. So as we have just seen that the assertion is true and the reason is false. So our correct answer would be option C in this case. Okay. So this was pretty simple question. Now moving on to the next one, 2021. Again we have got assertion and a reason. Okay. So first assertion is the SI unit of power is diopter. Okay. And the reason that is given is the power of a concave lens is negative. Okay. Power of a concave lens is negative. So basically if you look at these two statements, first is SI unit of power is diopter. Definitely that is true. Okay. But can we say that this reason that is given, whether it is a correct reason for this particular statement? So the answer is no. Basically it is not the reason, even though the reason or the statement in the reason is correct, but it is not the reason for this particular statement. So definitely both are true. So let's identify the option. Both assertion and reason are true, and reason is correct explanation of the assertion. So as we have seen, it is not the correct explanation. So here second option is assertion and reason are true, but reason is not a correct explanation. So this option has to be the correct option for this particular question. Okay. So moving on to the next question. Here it is. Again from the year 2021. Refractive index of a glass is 1.50. What is the meaning of this statement? Okay. So here you have to just talk about the meaning of this particular statement. When we say it is 1.5, what does this mean? Okay. So you can easily answer this question. Okay. Now moving on to the next question. What is a lens? List two main categories of lenses. In which categories is a double concave lens placed? Okay. Then next question here is a convex lens of a focal length 15 cm forms a real image at a distance of 20 cm from its optical center. Find the position of the object. Okay, so here we have to find the position of the object. That means we have to find out the value u, right? U is the object distance, v is the image distance. So here, in this case, image distance is given actually, okay, and that image distance is, here it is, that is 20 cm. At the same time, we have got this 15 centimeter, which is the focal length. So f is also given. Okay. So most of the things are given. We know the formula, 1 upon f is equal to 1 upon v minus 1 upon u. Okay, so we have to just put these numbers that are given here and we can just find out the value of u. Okay. Is the image formed by the lens magnified or diminished? So that also can be found out. We have got some formulas for magnification also. Magnification, as we know, is h dash upon h or also v upon u. Okay. So these formulas can be used over here and we can find out, okay, whether it is magnified or diminished. Okay. In fact, we know these cases also. We can directly also tell whether it will be magnified or diminished. We have already studied that, isn't it? In our book, we already have this in our syllabus. Moving on to the next question. Now we are moving to the year 2022. Okay. So here in the year 2022, at the beginning itself, we saw in the table that 17 MCQ questions were asked. Isn't it? 1 mark question. So let's look at these questions. Okay. So it's a 1 mark MCQ. Which of the following is a concave mirror used? Okay, in which of the following is a concave mirror used? So first is a solar cooker. Okay, so it's a concave mirror, remember, somewhat like this. Okay, as we know, in case of a concave mirror, what happens when the parallel beam of light or parallel rays of light fall on this concave mirror, then all of these rays are, you know, what happens? They converge at a particular point, isn't it? So when these rays, all these rays will converge at a particular point, okay, then definitely all the energy in these rays will also be converged, will also be focused at a particular point. So definitely a lot of heating will be produced, okay, especially in case of a sun rays. So in that case, we can use, okay, such kind of arrangement for solar cookers also. Okay, second option is rear view mirror in vehicles. So definitely this is not the answer because we know over here convex mirror is used. Then safety mirror in shopping malls. Again, here also we use convex mirrors. Then here in viewing full size images of distant tall buildings. Okay, again in this case also we can use the convex mirrors. But here in this case, in case of a solar cooker, we can use such kind of a concave mirror where energy from the sun rays can be focused at a particular point. Okay, so the correct answer should be solar cooker. Moving on to the next question. Here we can see 4 diagrams are given. So the question is, a student wants to obtain a magnified image of an object AB as on a screen. Which one of the following arrangements show the correct position of AB, that is object, for him or her to be successful? So there is a student who wants magnified image of the object AB. Okay, so in which case we will get a magnified image? As we know, in this first case the object is placed at 2f. So in this case we know a same sized image is formed. So this is not the answer. In this case the object is beyond 2f. So in this case also a diminished image is formed. So this is also not the answer. In this case, okay, over here in the last case we have kept the object at focal point. So in this case we know a image is formed which is very far. Okay, that means at infinite distance. Okay, but at that case, in that case we are not able to form the image on the screen. So that's why this should not be the option. So the last option that remains for us where the image is formed on the screen is this one, that is C. So here in this case the object is between f and 2f. In this case we know the image is formed beyond 2f where it is magnified also. So that's why this is the correct answer, and in this case we know the image is formed on the screen because it is real image. Okay, so this will be the correct one. Moving on to the next question. The following diagram shows the use of an optical device, okay, to perform an experiment of light. As per the arrangement shown, the optical devices is likely to be what? So here is some optical device. We don't know what kind of optical device it is. Okay, it may be some mirror, it may be some lens, whatever it may be. We have to just now find out what exactly it is, depending on what is shown here. That means the direction of the rays. So as we can see, according to the direction of the rays are concerned, as we can see here, that the rays, the parallel rays of light, after passing through this optical device, they are diverging, isn't it? Okay. So since it is passing through it and since they are diverging also, so this is something that is done by the concave lens. So the correct answer in this case should be concave lens. Okay, so this would be the correct answer. Moving on to the next question from the same year. A ray of light starting from air passes through medium A of refractive index 1.50, enters medium B of refractive index 1.33. So let's look at this statement first. A ray of light starting from air, okay, so there is air, it passes through medium A of refractive index 1.5. So basically 1.5 is a refractive index of glass. So we can say here there is a glass medium and there is air, okay, over here, and here it is the refractive index 1.5. Okay, then after that we have got another medium B whose refractive index is 1.33, and basically that medium is water. So let's say this is the medium 2 or medium B. Okay, refractive index is 1.33. Then finally it enters medium C of refractive index 2.42. So basically this is a refractive index of diamond, as we know. Okay, so these are the three, or we can say the air is also there. So 4 mediums are there. Okay, if this ray emerges out in air from C, then for which of the following pairs of media the bending of light is least? So here it is. So first, let's say this is the ray that is entering here. Definitely here there will be some bending. Okay, now here refraction is from rarer to denser. Then here, if you look at this, this is optically denser, this is optically rarer. So here in this case, the ray will be going away a little bit, isn't it? Away from the normal, like this. Okay, here we can see that the difference, okay, in refractive indices is quite less. Here air has the refractive index 1, is it? And the difference, if you look at this, it is about 0.5, and here if you look at the difference, it is very small. Then again here the difference between these two is very large, isn't it? It is of the order of 1, right? So since the difference in refractive indices, or we can say the ratios of refractive indices, which is called as the relative refractive index, okay, the relative refractive index between these two medias over here, especially if you look at this, that is quite large. So that's why here the bending has to be very much larger, and since it is traveling from a rarer to denser, it will be bending towards the normal. And again here we can see that the light is traveling from a denser to a very rarer medium like air. So here there will be a large bending, but it will be away from the normal. So the least bending, okay, would be taking place over here. That means this is medium A, this is medium B. Okay, so we can see here for medium A to B, the bending has to be less because the relative refractive index, okay, generally it is denoted like this, mu21, okay, mu2 upon mu1, or in some books it is also denoted by n21, that means n2 upon n1, okay. This is refractive index of medium 2 and this is refractive index of medium 1. So this number is quite large here or here, but it is small over here. So that's why in this case the bending has to be less. Okay, this has to be the correct answer. Moving on to the next question. For the diagram shown, according to the new Cartesian sign convention, the magnification of the image formed will have the following specification. So here the object is placed between F and P. Okay, in that case, in case of this concave mirror, what happens? We have to tell or we have to find out. Okay, basically in this case we know what happens. Generally in this case a image which is virtual in nature, virtual and magnified image is formed in this case. Okay, so that means we have to talk about the magnification, and we know for magnification it is image size h dash upon object size. So since over here image is formed somewhere here and it is magnified also, okay, and it is erect also, so definitely this magnification has to be positive first of all, and it has to be greater than 1. So correct option is B over here. Sign is positive and it is more than 1. So this is a simple question. Moving on to the next one. So a ray of light is incident as shown. If A, B, C are 3 different transparent media, then which among the following options is true for the given diagram? So here there is a diagram. This is angle of incidence, which is named as 1. This is incident light, this is normal, this is the refracted light, this is the normal, this is the emerging ray. Okay, so we have got 3 medias A, B, C. Okay, and these are the 3 different media. That means they are having different refractive indices. Okay, now this is the angle of refraction which is named as 2. This is angle of refraction, or we can say angle of incidence here, which is 3, and this is the angle of emergence which is 4, or we can say it is angle of refraction for this particular interface. Okay, so we have to find out the correct option here. So as we can see in the diagram itself, okay, over here 2 is quite small, then 3 is little bit bigger, then 1 is little bit more bigger, and last one, the fourth one, is even bigger. So here angle 1, okay, is greater than angle 4. No, this is wrong. As we can see, angle 4 is large. Then angle 1 is less than angle 2. Again, you can see angle 1 is larger. So this is also wrong. Angle 3 is equal to angle 2. So is it going to be the correct answer? Or last one, angle 3 is greater than angle 4. Definitely this is not the correct answer because angle 3 is smaller. But definitely angle 3 is equal to angle 2, because here we can use the geometrical property called as alternate angles. Since this normal, okay, they are parallel. So definitely this angle and this angle has to be equal, isn't it? This is called as the alternate angles, right? So they are always equal. So the correct answer over here is option C. Okay, moving on to the next question. Here it is. Here are some more questions. You can easily solve these questions. So if we have a lens, if a lens can converge the sun rays at a point 20 centimeters, that means it's a focal point or focal length, away from its optical center, the power of this lens is what? Okay, so this is quite a simple question. We can use the formula. Power is equal to 1 upon F. Here is F, but we have to first convert this in meter and put here. Then you can calculate this. Moving on to the next. The radius of curvature of a converging mirror is 30 centimeter. It's a converging mirror, that means it's a concave mirror. At what distance from the mirror should an object be placed so as to obtain a virtual image? So we have to get an virtual image. So we know virtual image is obtained only when the object is placed between the optical center and the focal point, isn't it? So here the focal point is at a distance, okay, at a distance 15 centimeter. Why? Because radius of curvature is 30 centimeter. That means focal point is, as we know, it is r by 2. So it is 15 centimeter. So if the object is placed between this distance, okay, then we are going to get a virtual image. Okay, so the correct answer is going to be this one, between 0 centimeter and 15 centimeter. And the next question is here, ninth one. The converging lens forms a 3 times magnified image of an object which can be taken on the screen. So it's a magnified image and it is obtained on the screen also. If the focal length of the lens is 30 centimeter, then the distance of the object from the lens is what? So again, we can find out this answer very easily, okay, because here the focal length is given. Okay, we have to just find out what the distance of the object from the lens. Another condition that is given is this one, 3 times magnified. That means magnification is also given to us, isn't it? So using these two properties and the formulas that we know, that is 1 upon f is equal to 1 upon v minus 1 upon u, and the another formula is this one, m is equal to v upon u. Okay, that can also be used and we can find out this. Okay, so these are some of the tricks that we can use over here. Moving on to the next question. Here it is. Which of the following statements is not true, or we can say false, in reference to the diagram shown? Okay, so the image is over here. So as we can see, it's a concave mirror and the object is placed where? It is placed at the center of curvature. Okay, so what will happen in this case? So first, we are talking about the statement that is false. So image formed is real. So definitely we know in this case the image formed is real itself. Okay, so this is going to be correct. Then image formed is enlarged. Okay, then image is formed at a distance equal to double the focal length. That means it is formed here. The image is formed here. Okay, then image formed is inverted. Okay, so as we know in this case, the image formed is generally inverted. Okay, or actually it is inverted. So we can trace also. If you first take the ray which is parallel to the principal axis, it will always pass through F, is it? And after passing through F, it will go like this. Then the second ray which is passing through this point over here, okay, over here it will follow the laws of reflection and the angle of incidence and angle of reflection will be same, and it will go here, okay, and these two rays are meeting over here. So the image is going to be formed over here. So the image is formed exactly at C itself, is it? That means this answer is also okay, this answer is also okay, but this answer is not okay because the image is not enlarged. It is in fact same sized according to the equations and calculations and the observations. Okay, so that's why this is going to be a wrong statement, but it's a correct answer. Moving on to the next question now. Here it is. So there is an image, as you can see in the diagram shown above. N1, N2 and N3 are refractive indices of the media 1, 2 and 3 respectively. Which one of the following is true in this case? Okay, so we have got 4 options, so we can easily identify from the diagram. So here first of all we can see the light is entering from medium 1 to medium 2 and it is bending towards the normal. This happens only when N2 is greater than N1. That means it should be optically denser and this should be optically rarer. And again we can see here, okay, that when it travels from 2 to 3, then again it is bending towards the normal. That means N3 has to be greater than N2, isn't it? So that means over here, using these two conditions, we can write the correct answer, right? So N1 is equal to N2, that is wrong. N1 is greater than N2, that is also wrong. Then N2 is greater than N3. Again, this is also wrong, but N3 is greater than N1, because you can see here N3 is greater than N2 and N2 is greater than N1. That means N1 is smallest. So definitely this is the correct answer for this particular question. Okay, moving on to the next question. The refractive index of medium A is 1.5 and that of medium B is 1.33. If the speed of light in air is 3 into 10 to the power 8 meter per second, what is the speed of the light in medium A and B respectively? So this is a quite simple question. You can easily solve this question using the formula N is equal to C upon V. That means this is the refractive index of a given medium and this is the speed of light in air or in vacuum, and this V is the speed of the light, okay, in that particular medium whose refractive index is N. So from here, since we have been asked what is the speed of the light in the medium A and B, so we can write here V is equal to C upon N. So here we can write this formula for medium A as well as for medium B. Is it? VB is equal to C upon N B. Okay, easily we can calculate by putting all these numbers. Next question is, an object of height 4 cm is kept at a distance of 30 cm from the pole of a diverging mirror. So it's a diverging mirror, that means it's a convex mirror. If the focal length of the mirror is 10 cm, height of the image formed is what? So what is given here? First, the height, okay, of the object is given. So we can write over here H is 4 cm. Then it is kept at a distance, that means object distance is given, which is 30 cm, but according to sign convention it is negative 30 cm from the pole. Okay, then the focal length is also given, is it? So F is 10 cm. Okay, and since it's a convex mirror, so it is going to be a positive focal length, right? Okay, because it's a virtual focal length for this particular mirror. Okay, now what is to be found out? We have to find out height of the image that is formed. So that means we have to find out H dash. So over here we can use the mirror formula, which says that 1 upon F is equal to 1 upon V plus 1 upon U, right? At the same time, we can use the formula for magnification also, right? Which is nothing but H dash upon H. Okay, so we can use all these formulas together and then we can find out H dash easily. Okay, so you can put these numbers and you can get the answer. Moving on to the next question. A compound microscope is an instrument. Okay, look at this. This is a case-based question. Okay, so a compound microscope is an instrument which consists of two lenses, L1 and L2. The L1, called objective, okay, forms a real, inverted and magnified image of the given object. So remember, it's a compound microscope, okay, which has two lenses, L1 and L2. L1 is objective, okay, and it forms real and inverted and magnified image of the given object. This serves as the object for the second lens, L2, the eyepiece. Okay, L2 is called as eyepiece. The eyepiece functions like a simple microscope or magnifier. It produces the final image, which is inverted with respect to the original object, enlarged and virtual. Okay, so now what types of lenses must be L1 and L2? Okay, so according to our experiences or according to what we have studied, we know both of these lenses are convex lenses, right? So both of these lenses are going to be convex. So that is going to be the correct answer for this question. So it's a very simple question. Okay, moving on to the next. Again, the case is same. As we know, it's a case based question. Case is same, the question is different. Okay, so this is the case. Again, you can see the case is same, but the question is different. What is the value and sign of magnification according to the new Cartesian sign convention of the image formed by L1? Okay, so this is lens L1. L1 is what? As we can see, L1 is the objective, right? So what objective does is it produces real and inverted image, isn't it? So if the object is like this, then the image is like this. Okay, so it is real, inverted and magnified. So it is bigger. Okay, so definitely we know magnification is image height upon object height. So since this is bigger than this one, m is definitely greater than 1. So definitely we have to look at those options in which the value is more than 1. Other options can be directly eliminated. Then since h dash, okay, you can see is in negative direction and h is in positive direction, so m is going to be definitely negative, right? So definitely this is negative, so correct answer is going to be option D. Okay, moving on. Okay, next again you can see the same situation is there, same case is there, just the question has changed. Okay, now here we are talking about L2. Okay, so what is the value and sign of magnification of the image formed by L2? Now in this case we can see here the eyepiece functions like a simple microscope or magnifier. It produces the final image which is inverted with respect to the original object, enlarged and virtual. Okay, so over here what happens is there is an object, then it produces, then the objective over here will produce magnified but inverted image, and this image is produced between the O and F of the eyepiece. So in that case an virtual, okay, magnified image is formed. So final image is here. For this eyepiece that is here, okay, this works like an object and this works like an image. Okay, it's a virtual image and this is the principal axis. Here is the objective lens, this is the eyepiece, okay, and this is generally the situation. So with respect to this object for this particular lens, we can see that the image is erect, it is magnified. So according to the value or according to the equation of magnification h dash upon h, okay, this is definitely greater than h. So m is definitely greater than 1, and since both are in the same direction, m has to be positive. Okay, so definitely over here in this case we have to look at those options where again this value is more than 1. Okay, here also other options can be eliminated and value or sign should be positive. So this has to be the correct answer in this case. Okay, value more than 1 and sign is positive. Okay, moving on to the next question. Again this is a same situation or same case, but the question has changed. If the power of the eyepiece L2 is 5 diopters and it forms an image at a distance of 80 centimeter from its optical center, at what distance should the object be? Okay, so this can be solved using some formulas. We have the formula of power, that is 1 upon f, then we have the lens equation 1 upon v minus 1 upon u is equal to 1 upon f. So using these formulas you can easily solve this particular question, isn't it? So you can just put all these numbers and all the data that is given and you can calculate f first, then you can go here and you can solve this question. Okay, now let's move on to the next. Okay, so here we are in the year 2023 finally. So complete the following ray diagram to show the formation of the image. Okay, so here we have got this object AB, this is ray 1, and here as we can see over here, this ray is a ray which is parallel to the principal axis, isn't it? So we know what happens. The ray which is parallel to the principal axis, it diverges in such a way that this will meet at F. This is F. Okay. So it will diverge in such a way that it will appear to be diverging from F. Okay. So this is how it is going to be, and since these two rays are meeting here, the image of this object will be formed at this particular position. So in this case, okay, what is going to happen is a diminished but erect and virtual image is going to be formed. Okay, so here we have to mention the nature, position and size of the image. So as we have just mentioned, it's a erect, it's a diminished and virtual image. State the sign of the image distance in this case using the Cartesian sign convention. So image is formed over here, so it is definitely positive according to Cartesian sign convention. Okay, so this is pretty easy question. Next, hold a concave mirror in your hand and direct its reflecting surface towards the sun. So it's a concave mirror, okay, which looks like this. Okay, direct the light reflected by the mirror onto a white cardboard held close to the mirror. Okay, move the cardboard back and forth gradually until you find a bright sharp spot of light on the board. This spot of light is the image of the sun on the sheet of paper, which is also termed as principal focus of the concave mirror. So some information is given, right? First question is least 2 applications of concave mirror. Okay, so as we know some of the applications of concave mirrors, right? Like there is a solar heaters are there. Then if distance between the mirror and the principal focus is 15 centimeter, okay, find the radius of curvature, okay, of the mirror. Okay, so this is given and we have to find out the radius of curvature, which is definitely double of this, 30 centimeters. Draw a ray diagram to show the type of image formed when an object is placed between pole and focus of the concave mirror. Okay, so we can easily draw such a diagram, right? If the object is placed between pole and focus, isn't it? So in that case, basically we know virtual image, virtual erect and magnified image is formed on the other side of the mirror. That means inside the mirror. It's a virtual image. Okay, another question. Okay, an object 10 centimeter in size is placed at a 100 centimeter in front of a concave mirror. Okay, its size is 10 centimeter and it is placed at 100 centimeter. If its image is formed at the same point where the object is located, find focal length of the mirror, okay, and magnification of the image formed with sign as per Cartesian sign convention. Okay, so again it is a very simple question. Okay, we have to just use the mirror formula, 1 upon V plus 1 upon U is equal to 1 upon F. Using this formula and the formula of magnification, which is image height upon object heights. So using these two formulas, we can easily solve this particular question. Okay, now here we are. Now what we are going to do is, we are going to have a look at the solutions, okay, for different questions from different years. Okay, so here is a question. Okay, this is from year 2019 and it was asked for 5 marks. Okay, so already we have read this question previously, just now we are going to solve it. An object is placed at a distance of 30 centimeter from a concave lens of focal length 30 centimeter. Use lens formula to find distance of the image from the lens. List 4 characteristics, nature, position, etc. of the image formed by the lens. Draw ray diagram to justify your answer of part 2. Okay, so let's look at the solution quickly. Okay, already we have discussed this question. What is given? First, object distance u is given, which is minus 30 centimeter. Remember, the object distance is always negative. Then focal length f is negative 30. Okay, here it is. It is given over here. It's a concave lens, and concave lens always has negative focal length. Okay, then we know the formula. Okay, so this is f, the focal length. Okay, v is image distance and u is the object distance. Okay, now what we will do is we will put all the numbers that we know. Okay, so putting the numbers in this formula, what we get is this. In place of f, we have got minus 30 and u is also minus 30, and after we solve this equation, okay, by rearranging, what we get is v is equal to minus 15 centimeter. Okay, so the image will be formed at this distance. Okay, minus 15 centimeter. So since it is minus or negative, that means the image is formed on the same side of the object. Okay, now moving on to the nature. As the image distance is negative, it is formed on the left hand side. Okay, that means on the same side of the object. That means it is a virtual image. Okay, position, it is formed between the lens and the focal point. Okay, as mentioned above, the virtual image is formed between the lens and the focal point. Okay, because we know focal point is at 30 centimeter, but the image is formed at 15 centimeter. So definitely it is between. And size, it is diminished. A concave lens always produces a diminished virtual image. Okay, and the image is erect, as all the virtual images are always erect. Okay, now moving on, we have to now draw the ray diagram, and here is the ray diagram. Okay, this is the object over here. As we can see, the object distance is 30 and focal length is also 30. That means the object is placed at f. So in that case, what will happen? This is the one of the ray that we are tracing. This is another ray that we are tracing. Okay, and after tracing these rays backwards, is it? Because this is a concave lens, so it is going to diverge the rays. So for an observer, if we trace these rays back, they meet somewhere here and the image is formed over here. Okay, so as we can see, image is diminished, it is virtual and it is erect. So this is the ray diagram for the particular case. Okay, now let's have a look at the description of this particular situation. So what we have done here is, for drawing this ray diagram, two rays are drawn from the top of the object. One ray travels parallel to the principal axis and diverges after refracting through the lens. Because it's a diverging lens, it's a concave lens, so it will diverge. Since the ray that we have considered is parallel to the principal axis, the diverging ray will diverge in such a way that if it is traced backwards, then it will meet at f, isn't it? As we had seen previously, okay, in this diagram. As you can see, if this is traced backward, it meets at f, isn't it? Okay, so then the other ray passing through optical center refracts undeviated in straight line. As we know that the ray which travels through optical center, it is always undeviated. Okay, so it is going to go in the straight line. Then these two rays intersect at a point behind the lens, forming the virtual image. Okay, then since the rays diverge after passing through the lens, the image is smaller than the object, that is, it is diminished. As both rays bend downwards, the image appears upright. Okay, that means it is erect. Okay, so this is a solution for this particular question and it is a 5-mark question. Okay, moving on. Now here it is. Here is another question. Draw a ray diagram in each of the following cases to show the formation of images when the object is placed first between the optical center and principal focus of the convex lens, and then anywhere in front of a concave lens. Then third is at 2f of a convex lens. State the sign and values of magnification in above mentioned cases, that is 1 and 2. Okay. So here, when an object is placed between the optical center and the principal focus of a convex lens, first case, this is going to be the ray diagram, isn't it? So object is placed between F and C, the optical center. Okay. So this is going to be the ray diagram. As we can see, one of the rays that is parallel, it will always go through F, and the other ray that is going through C, that will always be undeviated, right? And since they are not meeting anywhere, we trace them backwards and they meet over here. So the image is formed somewhere here and it is enlarged, isn't it? It is enlarged, it is erect, okay, and it is virtual. Since the image is actually not there, it is a virtual image, okay. Over here, O is the object and I is the image, okay. And this is the description of the particular case, okay. Moving on. Now let's go to the second case, when the object is placed anywhere in front of a concave lens. So this is going to be the ray diagram, okay. So over here again, O is the object and I is the image, and since the image is formed is virtual and erect, so sign of the magnification will be positive. So over here what we have done is anywhere in front of a concave lens, right? So as we know, for a concave lens, the image is always virtual, right? And it is always erect, but it is always diminished, is it? So that's why over here magnification will be positive, okay, and the image that is formed is diminished, okay. So therefore magnification will be less than 1, because we know formula for magnification is what? H dash, that is image size upon object size H, okay. So this is the second case. Now moving to the third one, that is when the object is placed at 2f of a convex lens, okay, and this is going to be the diagram or the ray diagram for this particular case. So here again, O is the object and I is the image, and here we know that when it is at 2f, image is also formed at 2f, it is inverted and it is of same size, okay. So this is the case, okay. Now moving on to the next question, okay. A student wants to obtain magnified image of an object AB as on a screen. Which one of the following arrangements shows the correct position of AB for him or her to be successful? So here we have got 4 options, as you can see. So what we want is magnified image and it should be on the screen. That means it should be real. So we have already discussed this case. So the correct answer for this is C, as we know, okay. The student wants to obtain magnified image on the screen, then the position of the object should be between F and 2F, because only real image can be formed on the screen. So we want a real image. So as we can see in this case, first case, we don't get magnified image, it is the same size because it is at 2F. Here in this case, the object is beyond 2F, so here we get diminished one, and in this last case it is at F, so here the image is not formed on the screen. So that's why this can also not be the option, okay. So these 3 are not the option, correct option is C, okay. So therefore this is the correct answer for this particular question. So in this way, now we come to the end of this lecture. So in this lecture we have seen many questions, or we can say questions that were asked in the last 5 years from the chapter light, that is reflection and refraction, okay. So we have seen multiple questions and different kinds of questions. We have seen some numerical problems as well as some short questions, some descriptive questions, some assertion and reason type questions, like. So we have seen different kinds of questions, isn't it? And we have seen some questions whose answers were given descriptively, okay, and some questions were discussed in short, okay. So we have done everything in this lecture today. We have discussed more than 30 questions in this video lecture, isn't it? So I hope everything that we have seen today is clear and well understood. Okay, so thank you so much for watching this lecture and best of luck for your exams. Thank you.